Welcome to Ask and Learn.
Here we have a position equation, and for part A we want to find the velocity. Remember that velocity is the derivative of position, so we're going to use the product rule to find the velocity. So we have the first times the derivative of the second plus the second times the derivative of the first, and we had to use a chain rule to find the derivative of e to the negative t. Now we want to simplify that, so what I've done is notice that you can factor an e to the negative t out of both terms, and you can also factor a t out of both terms. So I did that, and we get t times e to the negative t multiplied by negative t plus 2. And then to further simplify, I just changed the third term, or the third factor, and I called it 2 minus t instead of negative t plus 2. So that gets us in a good form where we can use it more easily when we move on. For part B, we're finding v of 1, so we substitute 1 into that velocity function, and we end up with 1 over e, feet per second. For part C, we want to know when the particle is at rest. And a particle is at rest when its velocity is equal to 0. So we take the velocity function and we set it equal to 0. We have 3 factors here, so we can set each factor equal to 0 and solve each one. So we have t equals 0, e to the negative t equals 0, and 2 minus t equals 0. When you have e to the negative t equals 0, it has no solutions because exponential functions are only positive. So the only two solutions we get are t equals 0 and t equals 2. So the particle is at rest at time 0 seconds and at time 2 seconds. Next, we want to know when is the particle moving in the positive direction. It's moving in the positive direction when it has a positive velocity, and it would be moving in the negative direction if it had a negative velocity. We just figured out when its velocity is 0, so to figure out when its velocity is positive, we can divide the number line into intervals, splitting it up at the time when its velocity was 0, when it was at rest. And so we have the interval from 0 to 2 and the interval from 2 to infinity. What we're going to do is take a number from each interval and plug it into the velocity and see if we get a positive or a negative. And for the first interval, I chose 1 because we already know v of 1 is 1 over e, so we already know that that is positive. And then for the second interval, I chose 3. I substituted it into the velocity and I got a negative. So what that tells us is that the particle is moving in the positive direction from time 0 to time 2. And we also know it's moving in the negative direction from time 2 to time infinity. All right, next we want to find the total distance traveled from time 0 to time 6. Now because we know it's moving in the positive direction some of the time and the negative direction some of the time, we have to break it down into those two parts. So it's moving in the positive direction from time 0 to time 2 and the negative direction from time 2 to time 6. To find the distance it moves in each direction, what we do is we take the difference between the position at the end of the interval and the position at the beginning of the interval. So the position at time 2 minus the position at time 0. And we take the absolute value for each interval just in case it's going in the negative direction and we end up with a negative difference. To find the values of f of 0, f of 2, and f of 6, you're going to use your original function f of x, or f of t as we called it. And I decided to work with exact values. I didn't approximate them at this point. So we substitute those numbers in. And for the first distance, we get the absolute value of 4 over e squared minus 0. And for the second distance, we get the absolute value of 36 over e to the 6th minus 4 over e squared. We're going to simplify those. And when we take the absolute value, what you're going to notice about the second one is its numerator is negative. And so in order to get the absolute value, you have to take the opposite of that. That's why it looks like all I did was rearrange my numerator. Now we're going to add these together, so we get a common denominator of e to the 6th power, and we combine the like terms. And this is the exact value of our total distance traveled. If we want an approximate value, we can just put that into the calculator, and we get approximately 0.993 feet. For part F, we want to draw the motion diagram. So now we know that the particle moves in the positive direction for a while and the negative direction for a while, so we want to show that with our motion diagram. So we start with a number line for s, the position, and we start at position 0 at time 0. Then we know the particle goes to the right until we get to time 2, and then we know the particle goes to the left after that. Part G is to find the acceleration, and remember acceleration is the derivative of velocity. So here's the velocity, and notice that it's a triple product. We have t, we have times e to the negative t, and we have times 2 minus t. And unless you really are gung-ho about using the triple product rule, I would suggest that we simplify our velocity equation before we find its derivative. So what I did was I multiplied the t and the 2 minus t together, giving me 2t minus t squared. And now we can just use the regular product rule, the product of two factors. So here we have the first times the derivative of the second plus the second times the derivative of the first. So I looked at that and I wanted to find a way to simplify it, and I noticed that we could factor e to the negative t out of both terms. So I did that, and that left t squared minus 2t plus 2 minus 2t. And then we simplify that quadratic expression, and we have our acceleration. Now we want to find the acceleration at time 1, so we substitute 1 into that, and we get negative 1 over e, and the units would be feet per second squared. Okay, for part H, we are going to use a graphing calculator and look at the graphs of the position, the velocity, and the acceleration. So you grab your calculator, you go to y equals, and you type those three functions in there. And then you have to think about what would make a good viewing window. So think back about some of the values you used in the problem, like we used times between 0 and 6, and we had some pretty small y values, things like 1 over e and so on. So for my window, I decided to try going from 0 to 10 on the x-axis and negative 2 to 2 on the y-axis. And you can make changes to those if you don't like them. But here's what the graphs look like. The blue one is the original position equation. The red one is the velocity, and the black one is the acceleration. And finally, we wanted to find when is the particle speeding up and when is the particle slowing down. So the particle will be speeding up if its velocity and acceleration have the same sign, both positive or both negative, and it will be slowing down if they have different signs, one positive and one negative. So we already know about the signs of the velocity, but we don't know yet about the signs of the acceleration. So before we can find when the acceleration is positive or negative, we have to find when it equals 0. So let's take our acceleration and set it equal to 0. Notice we have two factors, so we can set each factor equal to 0. And when we set e to the negative t equal to 0, we get no solution. And when we set t squared minus 4t plus 2 equal to 0, unfortunately, it's not factorable, so we use the quadratic formula, and we end up with 2 plus or minus square root 2. All right, so now what we want to do is figure out the signs of the acceleration and pair that together with the signs of the velocity to find where it's speeding up and where it's slowing down. So I made some intervals, and we have breaks at the intervals at the places where the acceleration was equal to 0, and we also have breaks in the intervals at the place where the velocity was equal to 0. Once we have those intervals established, we can find the sign of the velocity in each interval by plugging in a number from each interval, and we can find the sign of the acceleration by doing the same thing. And this is a great time to use your graphing calculator, go to the table, and you can type in different values of x, and then you can find the y values in your y2 column and your y3 column. All right, so you can see the sign results, and remember that the particle is speeding up if the signs are the same. So it would be speeding up between 0 and 2 minus square root 2, and between 2 and 2 plus square root 2. And then it's slowing down if the signs are different. So it would be slowing down between 2 minus square root 2 and 2, and after 2 plus square root 2. And that's what we have here.